So today let's discuss a little bit about Web3. It has been one of those topics which have had captured people's imagination, and I've been hearing about it since the start of 2022 like anything else, just like how I was hearing about NFTs in 2021. So let's talk about Web3 today. So before we dive into Web3, let's try to understand a little bit about the evolution of internet in general. Obviously, it all started in 90s with Web 1.0, which was simple text-based, pages. Then it came to Web 2.0, which created multi-stack, approach to developing web applications. And then, obviously, over time, it has evolved into semantic web, which is Web 3.0, based on how Tim Berners-Lee conceptualized it. But obviously, things have changed since then. In 2014, there was a concept which was coined by one of the co-founders of Ethereum network, and that was coined as Web3. Now, Web3 is complete reimagination of the internet as we know. It's not the same concept. It is about decentralizing the internet in general, which means that creating a new paradigm for distributed apps right hosted into the web. Now, having that out of the way, let's discuss a little bit about how a Web 2.0 application is really built. So essentially, for you to be able to build a Web 2.0 application or a normal internet application, you need essentially three things. The first and foremost thing is storage. You see, every time you go on internet, you change the state of the application you are interacting with, and all those changes of the state need to be captured somewhere. Like, for example, on YouTube, you might be creating a new video and you might be uploading it, and YouTube needs to make sure that it captures that event and indexes that video so that people could search and get access to that video. Anyhow, the key and the most important part of the Web 2.0 application is the storage. So given storage is one of the most important things, it needs to be highly scalable. It needs to be able to capture different kind of data without having to be relying on particular structure. So it can be a structured data like normal text files, or CSV files or JSON files, which, like for example, payment records, or it could be 100% unstructured data such as images, videos, and whatnot. Having said that, the most important thing comes out of is being able to identify this information and relay that to a right stack on the web. So for us to be able to enable capturing of all this information, pushing it down to the storage, it requires something which is called as a backend. So the backend system is the core of the web application. Now, what does that mean? It means that when you generate some data on the internet, that system goes ahead, tags the data, understands who is who, associates that data with you, and then indexes it. And then it puts that index out there on the storage so that every other application can access that data, which is connected to the web. Now, all this stuff is going to now culminate into something which is called as the front end. Now, for the user to be able to access these applications and data, you need to have some kind of a seamless front end. And that is where the interaction model comes in, which is your access to the internet, which is all these front ends, all the websites which you see around you. Now, so if you look and boil this whole thing down into a little bit of a structured architecture, it's a three-layered architecture where you have the front end, you have the middleware, and then you have the storage. Now, that's how every single Web 2.0 application is developed, come what may, whether it is a blogging website, whether it is a payment website, whether it is a banking application, whether it is a YouTube-like application, or it's a content application or whatnot. Given we have ironed out an application architecture for a Web 2.0 application, let's now start getting into how a Web 3.0 application really works and how it has to be designed. Now, given we started with storage, let's focus on storage. Obviously, the storage needs to be stateful, which means that it should be able to capture all these changing states as and when user interacts with the application. Now, the good thing with Web3 is that the blockchain, especially the Ethereum blockchain, has been designed as a stateful application. It is known to capture and maintain states in an immutable fashion. So at least that problem is solved. Now, in a web application, while it is quite easy and simple for us to change the state, it's not as simple on a blockchain. For you to make a change on a blockchain database, you need to follow a certain protocol, and every transaction must be properly validated and authenticated. Now, the biggest challenge with a blockchain network like Ethereum is that you cannot push state to the blockchain without having or following a particular protocol. And that's where smart contracts come into picture. Now, what smart contracts do, they define the standard with which a particular transaction need to pass through before it could be pushed over to blockchain. So essentially, what it means, the storage layer which we had in a Web 2.0 application now needs to be redesigned with certain smart contracts in place, and the backend is going to be a blockchain. Now here the complexity just starts. A normal user like me or you cannot interact with smart contract with a typical browser. What essentially you need to have is some kind of a node which basically executes these smart contracts every time there is some kind of an activity or an event which needs to be persisted on the blockchain. For you to be able to interact as a front end, this distributed Web 3.0 app, which is probably a website, you need to have your own infrastructure, which means that either you need to have your own node, or you will have to go out there and rent out a node from some of the providers like Infura, QuickNode, or Alchemy. Now, what is a node, by the way? Let me just describe. A blockchain node or an Ethereum node is actually going to be an all-encompassing source which will have all information related to the smart contracts needs to be executed, the event metadata, and what is basically considered as legal based on the protocol for a particular smart contract which is associated with a particular Web 3.0 application. And this is the first step for you to be able to interact with the actual application. So obviously hosting your own node is going to be very, very expensive because sometimes it takes days for a node to sync up. Plus you have to continue to sync up. It needs to have a lot of resources and capacity. You can't really do it on a laptop. So obviously it would mean that the best bet for you is to go out there and rent a node from all the providers. Now the good thing is this node is going to provide you the entire infrastructure. So it's going to provide you the layer which is going to execute the smart contract. It will give you ability to track all different events, and henceforth you can actually persist some of these states on the blockchain and retrieve some of the states from the blockchain too. Now obviously, as we discussed before, there are two different types of interactions you will have with any kind of web application. One is reading, the second one is writing. Let's discuss the reading first. Now, for you to be able to read any data from the application, you need to be able to have ability to translate the information, which is a bytecode information coming from the blockchain, into a more consumable form of information, such as JSON or something like that, which means that in the middle layer, you would have to have something which translates all the information into a human readable format, which could be then rendered as a website, and then you can access that website over time. So at this point in time, let's check our architecture. So now you have an application which has all its data stored on the blockchain. You have a node provider which is going to provide you all the infrastructure, which is going to help you take your events, map it to a particular type of a smart contract, translate it so that the network, which is the blockchain, can really understand who you are and what information you want to change. And now you have ability to also translate this information into a machine readable or human readable format which could come and get rendered on a website. But you're not done yet. For you to be able to make any change on the blockchain in terms of states, every transaction needs to be signed, which means that you need to have something which enables you to take your transactions, encrypt it, and sign it with your own private key to validate that it's you. Otherwise, it's not going to be able to persist. So for that to happen, you need to have something which is a front-end side or a front-end focused key store, which sits in your browser and takes every action which you do, signs it with your own private key, and sends it over for validation to the middle layer. Now this could be done by someone like Metamask. Now, as you know, Metamask can act as both the middleware, which is your nodes, as well as your browser side key management system. It kind of acts like both. So what Metamask does, it takes the activity which you want to push in, signs it with your own private key to validate it is coming from you, and make sure that all associated states or machine states behind the scene on the blockchain are updated. Up until now, it might sound really simple and easy. But now the complexities start to grow. Now you see, internet is a stateful system, which means every activity which you do on the web is actually noted. That's why it is easy and possible for us, for different companies, to do personalization. Now when you move all this stuff to Web 3.0 or the Web 3, for example, when you move all this stuff to a Web 3 architecture, the number of events and number of states which have to be persisted will grow exponentially high, and it will become very, very, very expensive for you to capture that much of storage and maintain that much storage on blockchain. And that is where third-party distributed file systems become very important. And these kind of services currently are provided by IPFS and Swarm. Now, obviously these are in infancy. There is a lot of work to be done to make sure that they persist and they scale well. But essentially, largely, if you look at IPFS and Swarm, they provide a reward to the node infrastructure providers for them to be able to use them as a storage structure rather than a blockchain. So now we have added a bunch of stuff to the three-layer architecture we had. We have added the front end, which is the web UI. We have added node infrastructure, which is going to do all the translation for the EVMs, the middleware, which is going to do all the translation for your smart contracts, the signing software, which is going to sign all the stuff which you do, the IPFS, which is going to be the distributed file system. And remember, there is also a reward layer now, which has to be provided by these distributed file systems for the nodes to have an incentive to go out there and use them. The three-layer architecture has already been changed into a 4 or 5 layer architecture. But the story has just started. There is more to do. See, to make any activity persist on blockchain, the computational overhead is very high. And given internet is more like a real-time system, it will not be possible for us to rely on this kind of an architecture for us to be able to get information in real time. There could be a scenario where you submit the request today and you get a response tomorrow because you're going to be queued. Now, how do we solve that? Now, this kind of a scale problem is being something which is being solved by companies such as Polygon and ZK Rollup. Now, what these guys do, as Polygon does, it creates a bunch of smaller side chains which try to do these transactions in real time, and they offload these transactions over to the blockchain, maybe nightly or weekly, based on whatever is required. Because ultimately, all these transactions need to be persisted on the chain no matter what. On the other hand, there are other companies such as ZK Rollup who provide specialized smart contracts such as Rollup smart contracts, which would help you roll up some of these transactions to a much higher level record, which can then be persisted to blockchain. But remember, these are all in very early stages. There is not an established scale or architecture yet. Now, let's re-evaluate our architecture again. In Web 2.0 as it exists, we had a front end, we had a back end, we had storage. In Web 3, we already have the front end, the signing authority, the node infrastructure, the distributed file system, now a bunch of side chains, and now we have blockchain. But guess what? There is still a part missing. Now you have all the stuff sitting on a highly distributed kind of an architecture. You cannot have your front-end application sitting on something like AWS or GCP. You need to bring that over to IPFS2 so that everything is heavily distributed and can be managed by a single infrastructure system. So now you have to re-architect your application to sit on an IPFS-like system. Now let's cobble this whole thing all together. Now what did we learn? Very simply put, a particular Web 2.0 application is a very simplified and standardized set of application architecture where you have to go ahead, where you build up your front end, which is context aware, you build up a back end, which is able to bridge between the storage layer and your front end, and that's it. And then you encrypt all the traffic behind the scenes so that it's safe, secure, and authenticated to the users who are authorized to access that particular information. Whereas in a Web 3.0 application, the entire thing has a much bigger complexity to it. Not only you have to redesign your front-end application to sit on distributed file systems, which are more peer-to-peer managed, you have to create a whole bunch of smart contracts for every type of an event which occurs on the application. Not only that, you have to build up a new node infrastructure as a backend, which can translate your events into machine-readable or blockchain-readable format. Once that is done, the whole retranslation has to be done back to the user. On top of that, you have to maintain a separate stack, which is going to sign all the transactions. You have to maintain a separate stack, which is going to bring efficiency by distributing these transactions on side chains. And then all in all, you have to bring all this together so that there are no race conditions between different states of an application, which could be millions depending on how many people are accessing your applications. So what is my take on this? Well, I think there are certain aspects of Web3 which are going to be very useful, such as bringing up zero-knowledge proofs. building up more distributed backends, which would help us make our Web 2.0 applications really resilient. But is it practical for all the applications to evolve with an architecture which is more over Web 3? I think that is not possible because there are a whole bunch of challenges which exist. And the mere fact there are multiple parties involved which own different important aspects of the Web3 architecture, that beats the whole point of it being 100% distributed. So with those words, I would say that there are certain things which become really buzzwordy, but the practical implications always depend on the simplicity of architecture. And given Web 2 is a highly scalable and simple architecture, I think it's there to stay. So with that, I will end the video, and until next one, stay safe, stay healthy,